Ladies and gentlemen, good afternoon. Hope you had a good lunch break. We're ready to go for the next session. Please welcome on stage Soren, Mark, and Gary. Thank you.
Good afternoon, everyone. Welcome back after lunch. Welcome to our session about how to write a repeatable software. There's going to be 4 of us today. We have a team by Vjekoslav Babic, we have me, we have Gary, and we're supposed to have Waldo here as well, but he was doing a multi-tenant environment implementation, and for some reason he couldn't spare off one more tenant to be here, so we had to replace him. We found a very good replacement with Soren today. Before we start the presentation, I would like to do an exercise. You have all been to lunch and maybe a little bit sleepy, so we're going to do a little bit of gym. I would like to ask everyone to stand up, please. Very good, very good. I can hear people say, "Oh!" But that's because they're getting old, right? So for everyone, if this is your first PRS session, please sit down. The first, if this is the first session. So a lot of people actually came to see us for the second time. If this is the second time that you see us, please. If this is not the second time that you see us, please sit down. So, and then everyone who was not here during our first session in 2011 can sit down too. Okay, so there's actually quite a few people who were here even for our first session in 2011. So let's go through the agenda today. We have 90 minutes and I just wasted 2 of them. We're going to start with an overview about PRS, and then Gary is going to talk about the methodology. After 4 years, we think we have a complete methodology on how to write repeatable software. Then we're going to do some out-of-the-box thinking. We're going to dive into some NAV 2015 features and how you can use them outside the context, or maybe inside after this. And then afterwards, we're going to talk about the roadmap, what we're planning to do after this. Let's talk briefly about partner-ready software and the history. I like to believe myself that it started with me writing a book in 2010 about application design. I just updated my book for NAV 2013. It's released in September, and I will update it for NAV 2015 as well. After I did that, Gary and Waldo approached me and said, we need to do something with this. We need to tell people about how to design proper applications. So we started the community initiative, Partner Ready Software. We started with the 3 of us first, and then Vjeko joined us, and now we have Soren with us as well. After a while, Microsoft approached us too. We went to Velbeck, did a presentation there, and we started the design patterns team together, which I think is a great step forward. Microsoft explaining design patterns. They will do it tomorrow. Tomorrow after lunch. I think it's great that Microsoft actually explains how they did the improvements in the system and tells us how the architecture works behind the scenes. So if we want to achieve the same experience, we actually know how to implement that. So currently we are with NAV 2015, it's the current release, and with this release, and also backported to 2013 R2, we have the PowerShell, and the PowerShell is actually one of the great tools that allows us to be truly repeatable. And for me, that completes the circle, and I really hope that Gary is going to talk about the methodology today, and I think we have a real nice coherent story now after a couple of years. So we started the design pattern project. We started it together with Microsoft. We started writing down design patterns. I think currently we have about 60 patterns, but I think there's way more in the application than what we have now. If you look at the screen, you see things that you might recognize, number series, documents, journals, copy document, all the things that we used to have in NAV for the last, 20, 25 years. But you also might see some things that you may or may not recognize, that things like hooks, encapsulation, readability, which are the PRS design patterns that we added. So if we categorize design patterns, we talk about architectural patterns, which are the documents and the code units and the big building blocks that the application is built of. Then we have the design patterns, which are the part of the architectural patterns, which are number series, blocked entity, the smaller address integration, so the smaller things, and then we have the implementational patterns. And most of the PRS patterns are part of the implementational patterns. They are more the way how I design things, how do I write code, how do I hook into codes, and what have you. So why is this all important? Thomas already talked about this during the keynote. The speed in which Microsoft ships software changes, and it changes fast. It used to be like 3 or 4 years between any major release, and that started to increase. The last couple of years we had yearly releases. Currently we have NAV 2015. Last year we had 2013 R2, but the R2 didn't really play it nice because it was a big release. And next year we'll have Corfu. And typically, if you look at how a customer treats the versions, they would skip a version, upgrade from 4 to 2009, upgrade from 2009 to 2015. And this is not the way we want customers to experience NAV anymore. On top of the yearly releases, we get the monthly roll-ups that contain hotfixes, regulatory features, but also whenever Microsoft finishes some feature, if it's not breaking anything, then they backport it into the roll-ups, and we actually get new features inside the roll-up. So we get those monthly releases, and instead of upgrading every 2 or 3 years, actually the strategy that Microsoft wants us to follow is to be always current. They want us to be always current with our add-ons, and they want us to be always software with our customers as well. So how do I stay current? First of all, the PowerShell. The new merge commandlets are great. They do a great job in helping you merging your software, dealing with conflicts. Then the design patterns. If you follow the best practices, then the chance for you of running into issues during your upgrade is way smaller than if you start reinventing the wheel, and you might actually do something that Microsoft did not anticipate on, and then you're on your own fixing your problem. Reducing your footprint is also a very good principle. The less you change in standard NAV, the better. Implement PRS, and then Gary is going to talk about hooks and facades and all the goodies that you get when you implement our methodology. It's all about upgrading in minutes. We want you to just go for lunch, start the PowerShell, and be back at lunch and then be upgraded. And it's about reducing total cost of ownership, and this is especially true for customers. I presented design patterns in St. Louis at NAVAC for end users, and every piece of software we write stays at a customer database for 10 or 15 years. And the easier it is for customers to bring forward their customizations, the more likely it is for them to stay current. And they, in the end, pay the bill. The fact that we are all here, the fact that we have all these great events like Directions. I was in Bali last week. We have this great event. So the fact that we have that is all paid for by the customers. So I would like to invite Gary to start talking about the methodology.
Thanks, Mark. So I'll try to squeeze what we have thought about in the last year into 30 minutes. since you're all sort of level 400, 500, 600, that will not be a problem. I have tried to divide what I'm going to say, speak about into 3 parts. What is repeatable IP? Just a very short introduction. Then how do I write repeatable IP? That's the main thing. And the third thing is how do I get started, so that when you go home, you can immediately, after this session, start doing so. There are 3 types of development that coincide with the development of the partner organizations that we're all working in or for and sometimes against. The first phase was that of individual programming, and that coincided with your partner organization trying to find your niche, trying to establish a footprint in your markets. Then we went to doing standardized add-ons that sort of began in the late 1990s. And we try to stand out sort of as industry domain experts and build a solid customer base based on one market segment, actually. And the phase of repeatable IP, which has begun, but actually is only beginning now, is that phase in where your partner organization wants to leverage the market segment that it's created to produce software and really create significant market shares. And what I'm going to tell you about the methodology is very valid and inevitable, I think, if you really want to do repeatable IP, cloud business, subscription model business, but it is valid for all other programming styles as well. It will just increase the value of your code. So how do I write repeatable IP? First of all, an overview again. There are 5 areas that I would like to go into today. One is agents, then we come to classes and methods, then we come to a special design pattern called facade, then we come to a very brief slide on design patterns, and then I'll try to wrap up what you can do when you go home after this conference. Now, agents, that's probably something that you haven't really thought about a lot, at least maybe not all of you. If you think, I have prepared an example of a medic, and you may think of him as being a vendor, but just think of the business content first. You have a person, which I call an agent, and he has several actions that he does, and they are defined. A medic can diagnose, he can treat, he can refer you to a different medic, and he will also probably invoice you. And he does this in several processes, in several contexts. You may think of them as document types or whatever, but they are like processes. Like he does that at his office, he does that on home visit, and he does that in the hospital. And if you want to combine the agent and his actions and the processes in software, it should somehow look like that. That is clean. You have the agent at the top, you have the processes that he does, and you have the actions that you can do on a very abstract model. But if you look into how we do that in code, and if I look into my code like 5 years ago, it looked more like that. We were sort of not referring to that as an agent who works in a process and does an action, but we were calling like code units and methods directly from the on-action trigger in the page. So the code looked more like unclean. Directly from the process, we go to an action, not even thinking about who is the agent, who is acting here, who does something. And if you add another agent to the equation, let's say a paramedic, it should of course be a different agent who is related to this one, but we kind of in coding sometimes put them sort of in the middle and let him do the same thing all over. And the fiendish thing about it is that this works, but it's not transparent. And if you want to grow your software and if somebody else looks into your software, he will have a hard time understanding what you've done. To translate this here into code, so let you maybe get an example of what I'm talking about by means of code. This is what we often have done in the past, and often still do. I still see that a lot in softwares. We have a diagnose action in a purchase order, and what we do is we call some code unit with some function. This code unit is sort of a functional collection of everything that the medic does, and we pass a code field as a reference. And then whatever that action is coded in that code unit. What I have told you we should be doing instead is something like that. You have actions defined on your agents, you call the agents and let him execute the action. It ends up with doing the same, but it's much more clearly structured and much easier to follow, and you always know if I have to execute an action, what agent is that on? I get him, and I will find every action that this guy is able to do on the agent. Translating that, an agent is a class, like in object-oriented language. In NAV, that will be like a table. An action is a method in an object-oriented environment, or a function in a code unit. I'm not looking at processes in this context. That will lead us too far. So if you do any sort of development, if somebody asks you to do something, gives you a task, start any development by determining who is acting. And the agent is always a class. It's always a table. There are exceptions to that rule, I know, but they are few. If you start thinking of who is acting here, you will always find that there's a table that is acting and that you can assign all relevant actions to. From that, so the advantages that you always have all possible actions defined on the agent. You can see that in IntelliSense just by pressing F5. You know what this class, this agent, this table is able to do. And every other developer and even every other consultant can actually see that. Let's jump into classes and methods. That's actually the biggest part. Classes that I've already said are tables. They carry all attributes and all methods that these classes are able to perform. Attributes are fields in NAV terminology, methods are functions, and all methods should always be declared on the class. All fields are anyway, we can't go around that. Vieco has shown that you have lots of possibilities to declare properties and fields in C# very freely. In text, we can't do that. All fields are always declared on the table in NAV, and that's what it looks like for the vendor. For the actions, for the methods, we have these choices that we sometimes not really apply in the best and most efficient and most transparent way. So our suggestion would be, what you do with the fields, please also do that with your methods that the vendor can do. If we say a vendor is the medic, then you should have functions, diagnose, treat, refer, invoice declared directly on the class. Just do that even if you don't have to do that. You also see here that there is hardly any code in these actions, in these methods. That is by design, although the methods are declared on the table, the code does not reside in the table. And we see where it sits a little bit later on. So that's what I already said. You see explicitly which functions exist for each table, which methods exist for each class, and which actions are defined for each agent. And that is actually the same on 3 levels of communication. So let's look into methods, because that's really how you structure that. That's really the heart and soul of your application. And we'll look into 4 categories, into encapsulation, readability, consistency, and decoupling. Let's do encapsulation first. Each method we recommend, and I ever say we recommend, like we're doing that actually with our software at eFacto, at Agilis, at a few other companies who follow that methodology. Each method is a code unit of its own. Like create recycling worksheet, that's from one of our verticals, find recycling company, move recycling entries, change sales business process, load recycling entries. Everything that you can do, all the actions, all the methods are just one code unit each. And I gladly take the opportunity again to ask Microsoft to give us code units for free. Because it really helps to structure your code, it makes code units much more readable. And then each method only has one global function. Since that does not involve any budget decisions, Microsoft has gladly already done something to help us in NAV 2015 when we've been in the keynotes. So when you open a code unit and you declare a new function, it is local by design. Microsoft thinks and we think all the functions in a code unit should actually be local except for one, and that is the method header that declares what this global function does. In this example, we have a method here called save allocation. That's about planned and actual cost allocation. And the method header gives you a sort of a flow chart of what this method does. And all the other methods that you see here are just calls to local functions on the same code unit. A method should also always be instantiated through its class. So I will never call this code unit save allocation through a code unit variable. We've seen that it should be declared on the table, and I always just reference it through the table. So I always call the agent, call the method on the agent, and then this invokes the code unit. We see an example here from code unit 80, where we've added a few functionality to the sales header, post plan cost, post conditions, post pallets, and these methods are declared on the sales header. They're in a with statement here, so that we don't even need to have the sales header dot post plan cost, and that actually saves you from declaring any variables in this code unit 80. You don't need to declare variables because the method is already declared on the agent, which is in the with statement anyway. So as soon as you think you need to declare a code unit variable, there's something wrong in the code. A method breakdown. What do methods do? Well, what should you do with your methods? Break all of your processes down into encapsulated methods. It is not quite easy to get the sizing right, I admit that. Like how small should the methods be, or how big should they be? There is conceptual work that you need to do, but we're talking about professional software production anyway, and that means you should put a lot of conceptual work into your architecture before you start coding. That's not always how we work, I know that. That's not always how I work if you're under pressure in a project. Well, we're talking about repeatable software product development here, mainly. But if you kind of do that and break all of your processes down, that allows you to put these methods together again as if it was sort of a scripting language. You know, when Vieco tells me about JavaScript, I always wonder, when does this guy start coding? He just collects functionalities that already exists and sort of puts them together. You can look at it. You can look at NAV this way. If you have all these methods broken down, it allows more high-level programmers to just pick the methods and put them in the right order, and that allows you to build new functionality and automated batch functionality on existing and already tested code. So from encapsulation, let's move to readability, which is not as technical, but just as important. We've seen that method header in the save allocation code unit, which consisted of a lot of lines of very readable code. That is how you should always look at your code units and method. The global function, the method header of each method, should be a readable flowchart of what your method does. A developer, when he has to do a task, he thinks about that flow chart in his head anyway. He says, okay, first I need to set a filter, then I need a repeat loop thing, then I need to initialize some variable, then I need to insert some variable. He has that all this flow chart in his mind. But what he often does then is just do the best in his code to hide that flowchart again in a lot of long chunks of very nerdy code. That's not the idea. You should actually break down the steps that you need to execute that methods in these parts that you need to execute, make them as small as possible so that each part only does one thing, and have a readable flowchart in your method header that tells everybody, including consultants, in natural language code what it is that this function does. That should sort of resemble plain text, this method header, and not carry any nerdy stuff and if you look at what I call nerdy stuff and non-nerdy stuff, cust.get is nerdy, getCustomer is not. I mean, that is a fairly irrelevant example, but I think you get the message. GetCustomer, everybody can understand that, whereas cust.get is already language specific. And this readable flowchart should also include all relevant steps, like not only check if I can do that, do that. Normally you have a lot more steps in between, and to structure that so that it actually works, that your method header includes all or most of the relevant steps that you do and does not omit one, is also not always easy to do, but when you start doing it, you'll get the gist of it quite easily. At least my developers have, and I know that Waldo's developer have, and even the ones, and especially the ones that come from a Visual Studio C# environment, find it very natural to code like that. And they say, well, do people in NAV not code like that? You're not telling me that, really, are you? Readability, just an example from another method in a vertical. This is about batch posting warehouse costs, something that some of you, most of you may have already written. So what this method does is defined by the method header. It says error if no period, error if no posting date, error if no location filter, or error if location filter too long, get cost posting number, commit transaction to database. And here's the first t-shirt. What is in the function commit transaction to database? What is the code in that? You don't get a t-shirt. No, you do. Yes, that's exactly true. I mean, sometimes it's very easy. Sometimes it's a bit harder. Then comes get the food set up, init rounding precision, clear general journal, and then we start force hide progress if no user interface, force non-transit filter on location because we don't record warehouse costs on locations that are in transit, and then we start post warehouse cost by location, and it goes on. So if you have an error and your customer complains, well, this your application throws an error just because there is no posting date. Please fix that. Then your consultant can look into that and say, well, it is an error, but it's an application error. It's not a development error. It has been done by design. He can say that reading the code. And that's not only valid for consultants, it's also valid for support. It's valid for any other developer who comes like half a year after that and needs to enhance that functionality. He can very easily understand what people have done, why they have done it, in what order they have done it, and also these functions, as you said, commit transaction to database, they are so tiny, you detect any error in that function immediately. They only do one thing, and they're very good at doing that thing. And if they don't do that thing, or if there's an error in that, it's very easy to spot. It's also very easy to enhance these parts or shrink these parts because they're not part of a huge chunk of 450 lines of code that are just with a lot of begins, end, repeats, and until loops, but they're just very defined and concise functions that are easy to handle and easy to understand. The process components, if you look into these code units that do a single action, and you look at a lot of them, they appear as different as they may be. They all end up having the same process components. That's really interesting. If you do a complete big software, and I've done in the last year a huge project with various completely different methods, very completely different actions, functions. If you look at these code units, they all have the same components. You have that method header, then you normally have some sort of validity check. Does this method apply to this data item or not, to this data entity or data item? You normally have a section that filters something. You normally have a section that loops something. You normally have a section that initializes data or updates values. And then you have a section with database transactions. Modify, insert, sometimes delete. And it's very interesting that all of these code units, as different as they are always built up from the same process components. And you can actually go through these code units and look for these process components. And if one is missing, and say, is that an error, or is that does this method behave somewhat differently? So you can even analyze your actions just based on process components and say, hey, you don't have a loop here. Do you think that's all right? Are you really just handling a single data item here? Shouldn't there be a loop section? Oh yeah, I missed that. It's sort of always the same if you do some meta-analysis of the code units that you have come up with. So from readability, let's move one step on to consistency. So, and that's consistency as seen in naming. There is a functionality that we've written, and I'm by design taking functions that are not part of NAV standard, but of an add-on that we've developed. We have a functionality that posts accruals automatically. So we have a page action that is called post accruals, ellipsis, ... We have a method declared on the class which is called post accruals. The code unit name is post accruals, or if you're a bit more legacy minded, you probably could also call that accruals-post, which would be the old NAV way of doing it. The method header is called post accruals. Development, I need to warn you, becomes boring, but it also becomes very transparent. And this transparency, you should really take a step further. The naming should be consistent in other contexts as well. Like posting accruals should be what a chapter in your process manual says. It should be on the help server. Consultants should talk about that. Salespersons and the sales material should sell the functionality as posting accruals. And a customer-facing feature description should also say posting accruals. Now, you may say that is all self-understood. Just look at what you have written and what your salespeople are selling, and even the language is completely different. Sometimes. Maybe you've had that experience in the past. I don't hope so, but I fear. At least I've had it. Now let's move a little bit more deeply into decoupling and a design pattern that is closely linked to the idea of decoupling. And that is what we call the facade. I know there are quite a lot of design patterns that are not called facade, but kind of do the same thing. It's not always easy to get the terminology right, but the term facade has worked quite well for us. What is a facade? It's actually quite easy after everything that we've just introduced in the last 10, 12 minutes. What you've seen is that I said a class, every method should always be declared on the class and be executed in a code unit of its own. So you have a direct connection between the class that declares the method and the code unit that sort of implements the method. Now these two objects, these two NAV objects, are both quite heavyweight. I mean, the table is the most heavy object in your in your object collection. There were a few versions of NAV in which it was not really nice to change the class, because then pages would kind of pop up if you inserted that new table and say I have a new field. It doesn't kind of match anymore. Okay, that's past us, but still the class carries your data definition, and the method carries all the IP that you have. So these are quite very important and heavyweight objects that you don't want to change too often. And they're linked quite closely, as everything in NAV, which is one of the very few drawbacks of NAV, as everything is linked quite closely. And we want to do something to decouple these heavyweight objects a little bit. And that's what a facade does. A facade is a code unit which you put into the middle of these objects to decouple them. So that's what it looks. You don't connect the class directly to the method, but you have a facade in between that does nothing else. There is no content code in that facade that does nothing else but know where this method is implemented. So it only finds the code unit that actually implements the action, the method that you want to execute from the class. And what good that is best made clear if you work with external components, like you have a weighbridge. If your customer has a weighbridge, he wants to attach that to NAV. Normally, if you have 3 weighbridges in your company, they come from 5 different producers. So the DLLs are always quite different, although the call to these of the actions are always the same. It's just get weight. And then you have to branch to 5 different DLLs depending on which weighbridge you connect to. So you don't want to have a hard connection between the class and the method that implements that, but you want to go through a middle piece, a very soft middle piece that just knows in what context what DLL is to be implemented. And if you take that out of the external component arena, and apply that to something like get sales conditions or get sales price, you may have completely different methodologies or approaches in getting the right sales price in completely different contexts for different customers, whatever. So you have the class, and you have 3 different methods of addressing a sales price, and the facade just knows which one to pick in which context. So you have a soft link to a multitude of methods. That's what the facade does. It decouples the class from the method, the declaration from the execution, and just finds the right place as an interface where the method is actually executed. And what it looks like is something like that. This is a facade code unit from our allocation table that we've talked about earlier, where you allocate planned costs, and all it ever does is just find the right method, the right method in that context. There may be actually more code. If you have like a case thing, it needs to find different methods, different code units depending on the context. And what you also see, there is one method here, save allocation, that starts with a completely different line. 40, you said? I must be finished at 40. You said? You didn't? Okay, sorry. Sorry, I'm over time, miscommunication. So what that does, it calls a confirm before the method and an acknowledge after the method, and the method in between. So it wraps UI. That's what you normally do. You have a confirm in front and an acknowledge after. And what the whole architecture is like, you call the class, which calls the facade, which calls a code unit that wraps the UI and then execute, so that you never have the UI in the same code unit as the execution. We have so many different clients, so many ways of treating stuff. It makes sense for me to sort of try and always encapsulate the UI and separate that from the execution of a message. So design patterns I can basically skip because facade has been a design pattern, and if you want, and which is one of the secret sources of NAV, Michael Nielsen is here and he can confirm that because it's his quote. If you want to learn more about design patterns, travel back in time to yesterday where we did a whole day on design patterns. If your karma is not enough for that, then go to the session of Bogdana Botez, Anders Larsen and Mostafa Balat tomorrow at 1:30 on design patterns. And just to wrap up in 60 seconds, an easy methodology, what you should do when you go home, establish your agents and actions model, break your software down into method and treat them as building blocks, as you've seen. Think of your method heads as readable flowcharts, provide decoupling, make your terminology consistent, and think and act in terms of design patterns. That's all you need to do to write repeatable software. And with that, I'm skipping a few slides and handing over to Mark.
Thanks, Gary. Yeah, there's a difference between talking until 40 minutes or until 40 minutes are passed with the 90-minute time slot. So last year, Waldo introduced hooks, and I think there's a great momentum this year for hooks with the new PowerPoint code merging, the PowerShell code merging. The PowerShell code merging really helps in moving your code forward, and the hook is a great way to reduce conflicts. You can make codes on pre or on post or somewhere in between. It doesn't really solve all the conflicts. If you write some code and Microsoft or another partner explicitly writes the code on exactly the same place, you end up with a conflict anyway. But if you implement a hook, it's not really a conflict. You can basically write some macros to ignore it. But this year we wanted to introduce a new idea that has been documented this year by Soren. Soren joined our PRS project. And Soren will talk about surrogate keys.
Thank you, Mark. So, well, when was it, a year ago, I joined the design pattern team with Bogdana. And I had an idea for creating something that was different. We're always talking about creating repeatable software. So software we can reuse, software we can plug in other places. Originally, I'm Danish, so I at the time called it Lego programming because I was thinking, I want a small block of something that just fits anywhere in the system. And I was trying to figure out, how can I do that? I mean, I'm of course limited. I don't have access to the platform, so I can't do a lot of changes. So I wanted to try and find out how could I, in some way in the system, exploit what is in the system and how it works to create a possibility to plug things in smart ways. So I came up with something that I later found out is called a surrogate key. And a surrogate key is basically a unique identifier in the database for either an entity in the model world or an object in a database. Yeah, well, that's something. But it's just a unique identifier on any record in a database that is not derived from any of the application data. So it doesn't care about what you have in the record. It's just a unique value. So I looked at this. Some of the generic functionality that I was thinking of creating was things like comments. Why do we have 28 different comment tables? I think it's 28 different comment tables in standard NAV. Could I add tags to anything I wanted to? Could I put documents on any record I wanted to and attach it to a document? Could I create user-defined fields? I showed this to Bas, and he came up with a few other ideas. There's tons of ideas where we can create things that we can reuse on any record in the system. So how could I implement this? Well, what I came up with was to use the auto increment property. So just create one field on a table that's a surrogate key, turn the auto increment to on, integer field, and do it that way. I consider things like GUIDs. GUIDs are not great on SQL. They don't really perform well, especially if you start having them in keys. And the other thing was that GUIDs or any other way of creating a unique identifier would require me to put code on every table. I didn't want to do that. I want to put my footprint as small as possible. So the auto increment and the integer field seems to be like the obvious solution. Then you can ask yourself, why not use the record ID? We have record ID. It works fine. Well, it has a few issues when you want to try and do something like this. The only negative thing I could really find with surrogate keys is I need to add it. It's not there by standard. Microsoft is sitting down here. So it would be great if it was their standard, but it's not there, so I need to add it on all the tables I want to use something for. Okay, it's one field, it's auto increment, there's no code, it's a relatively low impact on any table. Record ID already exists, way better. But if I need to rename something, record ID changes, I need to update all my records, I need to change it all over the place. Kind of not so good. My surrogate key, I don't care because it doesn't change, it has nothing to do with the contents of the data in the record. It stays the same. If I delete, there's some issues. I need to, of course, to delete the records in my whatever table I have that I have linked into my surrogate key. But I can manage that in Code Unit 1 on the global trigger. The same could be said about record ID. I think most implementations I've seen is always handled on the delete trigger. And then there's filtering. And filtering is another issue, and that's probably the biggest issue with record ID. If I want to attach, let's say I have created a comment form that's generic, so I can attach it anywhere I want. I can't filter on it with record ID without somehow implementing or putting in code into the system that passes this record ID so I can set a filter on it by code and reducing what I'm looking at. This sounds a little tricky right now, but I'm coming with a great example in a minute. The auto increment is much easier because it's a field in the table. I can just put a filter. So if I want to add comments to an item or to my rental item or to my service item, all I need to do is just add the page, put the filter, done. So I keep my footprint very, very small by using surrogate keys compared to record ID. So let me show you an example. Hopefully you can see NAV now. I should probably jump out of here and jump out of here. So here I have implemented a comment table. I've done it very simple. Easy comment table, has a table ID, has a surrogate key, a line number, that's the primary key. We don't really care about, from a data perspective, the only thing we normally have the user sees in a comment table, that's the date, the code, and the comment. For the rest, the user really doesn't care. So, based on that, I have created my 2 standard forms that any comment table has. I'm not going to go into that. You probably all know that. You've probably created comments on lots of your modifications anyway, where you basically take the standard Microsoft code and you redo it to fit your application. And then I have in Code Unit 1 added hooks down here. So basically, there's a hook here in the global triggers. So these triggers, they trigger anywhere across the system. So you have, there's a hook here that's calling my functionality. And of course, my functionality, and the one I'm most interested in this case is my delete. So of course it goes and I have my surrogate key management, calls my delete function, and makes sure that my comments are getting deleted if I delete the record. But I only need to do this one place. For the rest, I don't care which record I'm working on across the system. And as soon as I do this, I can now go to and actually implement it somewhere. In this case, I implemented it on the item. I did it on the item here because that was the record I had in the system. The standard database is pretty easy. And that way you could also see the difference between standard and this, which is nothing. So all I did was I added a surrogate key to my item table. Of course, made it auto increment. Auto increment, yes. That's fine, that's all I need. So now I have an anchor point on my table. That's all I need. I don't need anything else. I can now go to my item card. In this case, it's a table. It's an action. The comments are an action on it. I could make it a button on the page. I could make it a fact box. I could have made it anything I wanted to. But all I need to do to add comments to the item card is to go in, find out where are my comments, and the comments, I think I passed them. Where are they? Oops, no. Should of course have chosen one with a little fewer actions, but so here's the normal comments, and here's my comments. So I just added my comments here, and the only thing I did, add this one, point to my comment page, and put the filter, these 3 lines, I'm done. If I would create a new master item, rental item, I don't need to do anything except add this one page or this one line of code to my pages, that are the ones I wanted on, and I have comments. I don't need to redevelop comments. I don't need to create a new comment table. I don't need to create new comment pages. I have comments, and they work everywhere. And similar to this, so looking at this, I'm basically creating functionality that is, I'm just going to switch back to the other screen. So based on this, I'm basically creating functionality that's absolutely repeatable across the entire product. So I create comments once, I can use it everywhere. Like I said, what about tags? I could have created tags, and I can say, let me attack it, let me put tags on any table in the system. And say, I want tags, okay, doom. No development, no testing, because I've done that once. So basically what I just did here was, you see the standard structure on a comment table. That is, we attach we have a document header, we have a document line, we create a specific comment table to this document with the primary key. We do the same for a master item. We create a specific comment table to this master item with all the other fields. And then with the surrogate key, I just add a surrogate key to these master tables. And if that was there already, let's dream that it actually was something that was just in the system, and we could use it to do links. Oh, I have my arrows dropping down here. I forgot to push twice. Then I can create my functionality. In this case, again, I'm using the comment table just because I think it's a great example. I create my comment table, functionality, standard out of the box, no special features. And I create my page. It actually looks exactly the same page. If I take a standard page from the current system, it will look like this. And I create both my list and my sheet as standard implementation of comments. And I just add my link on my fact box, and that's the only, this step, once you have done the other steps, this is the only step you need to do in any future, except, of course, adding the auto increment key. And of course, you need to have the hooks. If this is the first time you're implementing a new pattern, you need to make sure there's hooks, and you need to make sure that hooks here, of course, we've got to promote the hooks. Waldo is crying if you don't promote the hooks a little. So add the hooks, but again, this is only the first time. The second time, the third time, the fourth time, you don't need to do anything except add the page and make sure that the records are deleted is the last step, which again, that's completely generic. You can just use the record refs in the system and completely generically delete these records, no matter which record you're actually deleting, as long as it's linked back to my standard table. It's completely generic. There's no code. When you've done this once, you never need to think of it again. The only thing you need to do is just add the circuit key if it's not there, and add the link. And that's generic code. This is low impact. It reduces your testing. It reduces the amount of work that you're doing to actually implement new functionality. So here's the complete, truly generic and repeatable code slide. And that's out of the box, new way of thinking, a new way of coding. And back to Mark.
Thank you. So now I wanted to take the next 10 minutes and share with you some out-of-the-box ideas that we within the PRS team got when we saw all the goodies that we're getting from Microsoft with the NAV 2015 release. And the first thing I want to share with you is the Delta file. The Delta file is something new that we got with NAV 2015. And the thing I want to discuss with you today is I want you to start shipping deltas. So this is the slide that Thomas showed us this morning. We have a base database that has a couple of fields. We add a field to the table. We have a target that we want to move to. And in order to move our change forward, we implement this new object type, and by moving the object type forward, we can apply the delta to the new database. So this is the delta, and this is the way we can use it within an upgrade. If you use the PowerShell, there's two ways of doing the PowerShell. You can do the PowerShell with the delta, so physically creating the delta file on the disk, but you can also do the PowerShell without the delta, and then everything happens inside memory. But what I would like you to think is start using the delta for much more than just within one upgrade. If you're an ISV like Agilis or Lanham or OP+, you're most likely to ship software to your partners. And traditionally, the way we ship software is we make a FOB file, and then we send that FOB file to the partners, and then they start playing around with it. And basically, what we think is that with the PowerShell, a new star is born, and a new star is the delta file. And instead of shipping FOB, we would like you to start considering shipping deltas instead. You can ship the delta to any partner, and the partner can use the PowerShell to start applying the delta to their own objects. There are some good and bad and uglies to this. The good thing is it saves just a whole bunch of time, because what happens at the partner that receives the software, they take a Cronus database, they import the FOB file, they export the text, start merging it against their own software, and those are basically all steps that they can save they can basically put all the deltas in a folder and immediately start applying the deltas to their own database. There's some bad things. You have to start fiddling around with the version list. There's a couple of scripts that can help you doing that. Conflicts are quite hard to handle. I already talked to Per Mogensen about this, and he's thinking about expanding his merge tool with allowing you some user interface to handle the conflict files. There is some ugly that we are talking to with Microsoft, with Michael, that basically if you ship a new table or a new field as a delta file, the delta file is actually just the object file, but the current situation is that the object designer, the application development, does not allow you to add any objects outside of your license range. And our suggestion is that to move that away from the object designer and just let the customer license file handle that. I think we are responsible enough to add a table and to add a field, and eventually, if the customer ships, if the software ships to a customer, the license file of the customer will solve this. So this is something that is on our wish list, and we may or may not get it in the future. We don't know. Waldo's doing his PowerShell session tomorrow at 9 a.m. I really encourage you to be there. He's going to talk about more about this. So that's the first thing. The second thing that we got with NAV 2015 is a new object type called upgrade code units. And the way they are designed is the idea of upgrade code units is to make life easier doing upgrades. Traditionally, an upgrade had a step 1 and a step 2. Step 1 upgrade moved the data away from the tables so we can apply schema changes. And then step 2 is doing some business logic to put the data back. And the upgrade code unit basically replaces step 1 and step 2. And step 1 is handled by some generic piece of code that saves you the time of writing all this. But if you look at the way that these upgrade code units are processed, they are part of the shipping of the FOB file. What happens if you import an FOB file, the system checks if there is an upgrade code unit. And if there's an upgrade code unit, it will start executing the upgrade code unit and it will implement the step 1. So it will move the data out and it will allow you to apply schema changes. And then after the FOB file has been imported, the UI of the development environment allows you to execute all the upgrade routines. So the thing we want you to start thinking about when you get your hands on playing around with NAV 2015 is to think about the upgrade code unit outside of the traditional upgrade context. And it's basically a platform to do any data conversion with any FOB. So anytime you're during an implementation, you have something the way you want to apply data conversion, think about doing the upgrade code units as a solution for that. You have to keep in mind that the system just looks for any upgrade code unit in the database. If you run the preconditions, make sure that you check the version and that you don't start applying upgrade code units to the wrong version. And make sure that your upgrade code unit is self-destructing. I tested this. It works. So you can basically, if you apply an FOB file and you ship an upgrade code unit, you can basically delete the code unit afterwards. So that you don't run into the situation that by accident, if you ship the next FOB, you start upgrading or start running the wrong upgrade code units. So with this, I would like to introduce Vjeko, and he's going to talk design patterns through .NET. And after that, I will be back with you to wrap up.
Thank you, Mark. We need to switch laptops.
Yeah, we need to switch. You have the slides yourself. You have the slides.
I think I do. Yeah, that's true. I need the slides. Yeah.
So you need to switch back.
No. I will
Okay.
I will handle that. So I will somehow just have to open my slide deck. Actually,
Switch back.
I apologize. Yes, I'm switching temporarily back. Okay, so thanks to Mark for the introduction. It's something is still not quite. Yeah. Okay. So this is my first time actually speaking as a part of the PRS team. It was kind of the goal of Gary and Mark and Waldo to get me on stage for the past, 3 years. But it just never happened. So this time they succeeded. So when they told me like, can you do some of your stuff? And when they say your stuff, they mean like .NET and JavaScript. So I asked like, should it be JavaScript? And Gary said no, because like in JavaScript you don't ever see any code. It's just pull the things which are finished and just put them together. I asked like, isn't this the ultimate design pattern? Like just put the things together and it works. So I decided to actually do it in .NET. So the problem with the design patterns is that many people think that design patterns just do not work in functional languages, and they're almost right. Because in functional languages, you have very few patterns on your disposal. Whereas in object-oriented languages, you have a lot of patterns. And the primary reason why you have a lot of patterns is that you have polymorphism. Essentially, the polymorphism is the cornerstone of any true extensibility. So if you want to have extensible thing, you need to have some kind of polymorphism, at least if you have strongly typed languages. So what I'm going to do is essentially explain a little bit about one single pattern. Because I only got 10 minutes on stage, I'm going to explain one pattern which kind of allows you a lot of flexibility with extending your application, writing repeatable stuff, etc. So what I will start is the service locator pattern. The biggest problem with NAV, as we have seen from Gary's presentation, is tightly coupled code. We have code which calls other code, which then calls other code, which may be calling back. So it's very difficult to, for example, have you ever had to debug, let's say, inventory adjustment or, I don't know, sales posting and stuff? It's essentially, it's one big bowl of spaghetti that you somehow need to find your way through. And we are aiming at extensibility, at decoupling stuff. So essentially being able to add stuff in or take stuff out or replace stuff easily without having to code too much. This service locator pattern, it is essentially an incarnation of not a so-called, but really of the inversion of control pattern. The point of the inversion of control is that my code calls your code, but it doesn't do it directly. It actually uses somebody else in between who actually tells me which code I should call to. Or actually, it kind of hides the detailed implementation of the service, in this case, that I'm calling into, and it allows me to actually just talk to an interface which knows which things I'm trying to achieve, but doesn't know how those things will be achieved. And if you think, for example, from perspective of NAV, here I'm going to take a very real-life example of synchronizing data in NAV with an external application. So what my code in NAV needs to know is what I need to do. I need to take data from somewhere, and then I need to somehow store this data in NAV. How exactly I'm doing that? It's not my concern. So I'm calling a service which does that. And as far as I'm concerned, it can be any service in the world. So the only thing that I care about, there is a common interface that I call into. And the goal of the service locator pattern is to help me find the correct interface to achieve that job. So let's take a look at the situation as it is. For example, we have some class A, which can call service A, but it can also call service B. And for this class to work, this class has to be aware of both services, essentially at the compile time. So when I compile a piece of code, what I need to know is which are these services. And essentially, if I change service A, it's very likely I will need to change the class A, which might in turn trigger me to having to change the service B, which is what tightly coupling is all about. So let me actually show how this tight coupling looks. I will do the demo afterwards. Since I have to go through the slides first, there are very few slides left. So the solution to this problem is to introduce a locator in between. So my class instead talks to the locator. It doesn't talk directly to class A or, service A or service B. So it calls the locator. The locator locates the services, and then my class just continues working. And if anything is changed, I actually never need to change service. Actually, when I change service A or service B, or I introduce service C, my class A should stay the same. I shouldn't touch class A, which means my NAV code stays the same. So, and now I demo the solution. So I go back, demo the problem, and then I demo the solution. Okay, am I live? Kind of. Okay, so I will start NAV. I'm going to synchronize the employee table. And it's going to be a very, very basic example. Okay. So here's the employee table, which has some employees, and here I have added two actions. First action is called sync employee data, tightly coupled. The second one is sync employee data decoupled. So when I click either of them, both of them do the same thing, essentially, they synchronize the data. So when I click that, what happens? Essentially, what happens there is that my NAV web service integration code unit is invoked. So let's actually take a look what this code unit does. I have this service thing. It's essentially a DLL which contains proxy classes for the NAV web service. And inside of this class, what I'm doing, I'm going into essentially the same database, just another company, and reading the data from there. But how am I doing that? I'm doing that in this way. So I first instantiate this service directly, then I set some properties directly. And then I retrieve the employees. And the problem with this employees class, or actually this array of the employee class, is that it depends on the service. It's the service who tells me what I need, what the data is. So if I take a look with F5, this employee actually has properties that come from that external service. I might not need them. So imagine that a property changes name, okay? Suddenly my code is broken, it doesn't work anymore because the property that my code is aware of doesn't work anymore. So you change service, you have to change this code. So that's one of the problems. Second problem is that I'm, of course, tightly coupling practically the whole thing. The data collection and the data model itself. So both of them are tightly coupled. Solution for that would be a bit different. So if I go to Visual Studio, I would start, it would be a two-step process. The first step in this process would be to actually decouple the data model first. So I don't care if this target system has 70,000 fields in this employee class. What my database cares about, or my solution cares about, is maybe just these 7 fields, nothing else. So I expose an entity class which contains only those fields that I'm interested in. I don't care about other fields. And I don't care if the fields have the same names or whatever. I just care that this is the entity class. And I'm going to operate on this entity class. The complexity of the actual implementation is hidden away from me. The second thing is essentially wrapping the original service into a wrapper. And this wrapper has one single method, which returns an array of these employees, actually array of my entity, not their entity, which was NAV entity. And essentially, the only method which is relevant is this get employees. However, this is not decoupled enough. So the next thing I do is I introduce an interface. So I declare an interface which is called employee integration, and this employee integration has the only thing that I really care about, which is the method which gets the employees. So my NAV code is going to talk to the interface, not to the implementation of the interface. So I don't care how the employees are retrieved, I just call this method. And then next step would be, of course, to simply implement that interface. So essentially I implement this employee interface on my class. In the future, if I have another like file system integration, like somebody's shipping files to me as a CSV file, I create another class which I call file system interface. Again, I implement the employee integration. Again, I have get employees, which works in a different way than the original one. It knows how to handle a different system, and then I call that system. And in CAL, I have this service locator. I will take a look at that later. This is the decoupled invocation of this service. First, okay, this employee delete all is just there to show that stuff is really happening. Instead of instantiating and connecting directly to the service, I'm invoking the locator, and I'm asking the locator, get me the interface. And I just pass the interface, this employee interface, to the service locator. And then here, I invoke the getEmployees method on the interface. If I take a look at the interface class, it just has that method, nothing else. But I know that it returns to me the array of the entity that I'm interested in, this one, my entity, okay? And essentially, this piece of code works regardless of what is on the other end, NAV, file system, SAP, CRM, whatever. And then let's take a look. So here, back in, if I click this sync employee data decoupled, let's take a look what this service locator is doing. So I'm going into the service locator. Essentially, I'm going to human resources setup, and I'm checking, okay, what kind of service am I using? Am I using employee integration type, or am I using, NAV web service or file system? So let's switch. Let me go into the human resources setup. And let's switch into the file system integration. Okay? So both of these methods here, the web service integration thing locates the right service for me. It sets specifics for that service. Okay? So in the very worst case, this is the part of code that I need to change. It can be automated as well, but it will be an overkill for 10 minutes in this presentation, which I've already overdue. And here is the specifics for the file system. So it goes to the file system, loads a CSV file, and then feeds the data. So if I click sync data decoupled, it essentially reads data from the file system and integrates them. And I didn't have to change a line of code in CL, for example, if I want to go on with a different kind of interface altogether. Okay. Thanks. Yeah, thank you.
Okay, let's wrap it up. I want to have a couple of minutes for Q&A. I'm afraid that's going to be tough, but we'll try to do it anyway, and we're prepared to stay after. So, looking back at the last couple of years, we have achieved a lot. We have got a lot of things in the application. Just a few to mention: expanding and collapsing functions. Longer function names, automatic population of variable naming. For those of you who were here last year, you might have heard me talking about data dictionary. This is like a very tiny version of a data dictionary, but it's better than having nothing. I'm really happy with this feature. We got automatic merging. We can start thinking about delta files. So there's actually a lot of things that started happening in the last couple of years. That doesn't mean that we are happy with where we are. We have a couple of wishes that we have. A couple of them Michael already talked about this morning. For each, easier integration. There's a couple of things that are harder to reach, and we know that, like enumerators or reducing code loading. One of the things we want to elaborate a little bit more at the moment is connection to TFS. TFS or Team Foundation Server at the moment is kind of a moving target. If you start talking about doing a versioning repository, it's kind of difficult at the moment to make a decision if you go for TFS or Git. Git is a really cool way of doing your repository. It integrates with Visual Studio, but Team Foundation Server has a great UI. It allows you to create tasks. It has Kanban board and what have you. And if you went to Luc van Vugt's session last year, or you viewed one of the online videos about that Soren Klemmensen did on Team Foundation Server, you will have learned that there's actually nothing standing in the way of you starting to do Team Foundation Server today. There's a perfect methodology you can use. You can start implementing it. But we would like to take it one step further. And the comparison we prepared for today is basically, again, going back to the upgrade. If you look at the development environment, there's a drop-down list where you can start the data upgrade. This helps you because you do not have to go to PowerShell necessarily, but basically it executes the same code as the PowerShell is executing. So we have a whole bunch of PowerShell commandlets that do the upgrade, and we call the commandlets from the user interface in the development environment. We think that we can do exactly the same with TFS or Git. And actually, you can do it today. There's nothing preventing you from doing this. We have a whole bunch of PowerShell scripts, and you can actually script the integration with PowerShell and script your way through integrating stuff with TFS. But we think it would be nice if we do that. You can do it. Microsoft can do it. That if we take it one step further, if we do it in the development environment like we do with the upgrade, so that we have a true TFS integration in the development environment, we think it will help partners adopting TFS because it's part of the user interface like it's in Visual Studio, without having to invest too much in it, because you can already do it today with the PowerShell. Wrapping up, we are doing workshops. We have a whole bunch of workshops going on in Germany, the Netherlands, Belgium. I've been asked to go to India and Japan. We're going to do workshops in Atlanta. We want to get this out as much as possible. We want to talk about the design patterns. We had a class yesterday. Waldo talked about the PowerShell. And we think this is a great momentum where everything comes together. The design patterns, the upgrade code units, and the PowerShell all really ties in about how to write repeatable software and how to really start reaching this multi-tenant, 10,000 customer momentum. There's really nothing standing in your way anymore. So I would like you to leave with a quote. It's my quote. A professional partner channel deserves a professional work environment. Just think about it. I know it can flip into two directions. It can say something about you as a partner, or it can say something about a professional work environment. It's up to you what you want to think about it. So partner-ready software, it's you, it's us. Partner-ready software, we're a community. This is all what we could think about in the last couple of years as a methodology, and I would really like to urge you to start using it. Start using the methodology and start getting these multi-tenant installations going. Questions? I would like to have my fellow partner in crimes to come with me and help me asking the question, answering the questions.
We should give these ones away too.
We have a whole bunch of T-shirts for anyone with questions. I don't know if there's someone with a microphone running around.
Yeah, we repeat there.
I can't see anything with the lights.
There's one here.
So, any question? I'll go with the microphone up front over there. Just a second.
It's coming a microphone here.
Excuse me.
There was somebody.
I would like to hear what the reason was for putting each method in a code unit on its own.
Basically, encapsulation, basically to have, to not pair two methods together in the same object, but be able to treat it very independently and in a very encapsulated way. If you have two methods which do different things in the same code unit, you have two global functions, and it's harder to differentiate that. Also, if you put it in one code unit, you can actually have access rights for each individual method, each individual action, just by defining them on the code unit. There's more to that, but it's probably not more time.
There's another question up in the back. Microphone is going up there.
I also have a question regarding code units. I often have the case that I need one method, but in different variants, like overloading a method in .NET. What are your thoughts on that? How would I model something like that? Maybe a logging function with multiple variants where I need more parameters.
Please, Michael, overloading is a good idea.
I already bailed out.
Okay. Pardon? And Bogdana has a design pattern for that. Enlighten us.
There's a design pattern that you can use for that. We're going to talk about it tomorrow at the design pattern session, but basically you want to overload, meaning that you want different arguments for your function. So if they are not records, then just put them into a table. So then you can put whatever you want into the table, and then you change function behavior based on what's in the table. That's
basically,
very shortly.
you have a table that you never populate with data just as an arguments table. Is that what you're saying?
Yeah.
Just like, okay. So the arguments design pattern is a way to do that. You have specific arguments that are valid at one time and not valid in a different context. You just pass that arguments table on. Real overloading would be nicer, but that's our workaround for that. Make sure you claim your T-shirts.
In NAV, you have a security based on table. When you use generic key, how do you manage the security?
So I guess that was a question for me on security. Many of these tables are typically things that are quite widely used across the database. So if you have like comments on a customer and a vendor, and you don't want him to be able to modify security on the vendor, you can use the security filters. They work perfectly fine on that. And you can actually limit that he cannot, because the table ID is in there as part of my key. So that's the easiest way of doing it. I'm sure if Pierre is in here, I don't know if he's in here, but I'm sure Easy Security also has some great ways of fixing that.
And also the comment thing is just one easy example that everybody can understand quite easily. I even find that the tags example, even from a business point of view, much more interesting. And there you don't have the security issues because you want people to be able to search across the whole application. That's exactly what the target is.
Exactly. I mean, it's just one way of implementing. What I showed was just one way of implementing it. There's so many examples out there where you can just use this to really create generic functionality that can be applied everywhere. And I mean, comments, tags, editable fields, you can keep going, documents, pictures that you can attach to any record. You can keep going. There's tons of things you can do to the application where you really can make it generic. And not always is security really a big issue on many of those areas.
Some questions over
There's
there?
a question over here.
Okay.
No?
I have
Oh,
one question
sorry.
to Gary. You told us that it's better to do the functions or the methods directly in the tables. And I remember in the past there was a maximum possibility of doing fields in a table. Is there also a maximum quantity or number of functions or methods in a table, or is this without a maximum?
There used to be the case, but there is no maximum anymore, not as far as I know. And if you have like 2,500 methods for one agent, there's probably something wrong with the architecture anyway. I have not run into any sort of problems now. So I don't think that is an issue.
Okay, thanks.
Really not, yeah.
If you have one global function and the rest local, how do you unit test your application?
I would actually more see it the other way around. It's you only hit that code unit through this method header, and then everything is done inside that method. You test the result of the method that you execute. I don't think that there is really an issue here. Would you believe that there is an issue in unit testing?
No, it depends on the structure of the code. So if we take a look at those method code units, essentially every method is atomic. It needs to achieve one single task, like complete an action. And essentially if you're unit testing those actions, then you need to test them as a whole. And those smaller functions which belong to that, let's call them method code units, those local functions in those code units. Essentially, I could agree, you might want to test them independently, but there might be no use of that, because constructing the context for proper unit testing of them might be difficult. And then again, if you're testing repeatable stuff, which is called from multiple code units, then you wouldn't have duplication anyway. You would put it in another code unit. So this design pattern doesn't imply that everything belongs there. You will still have common code units with common code that you don't duplicate around, and you would unit test that code. So that's how I would approach it.
And that's actually correct. I mean, it's the smallest bit of process that you test. You don't test a get customer just because it belongs to the process. You do that all over the place. What you test is actually this specific method. And if the method fails, then everything fails. You should look at this as the smallest unit of that you do. And the local functions are really just helping to establish that sort of method.
But I think I say thank you to whoever asked the question, yes, because it does open some questions for us. So yeah, it really, I mean, we have now answered, but it doesn't mean this is the ultimate answer and that we are not going to think about that, because it is a valid question.
You need to come back next year as well, so we have to.
Excuse me. Yeah. Usually in a project, we work more than 2 or 3 developers, and everybody ends up making his own methods. So how to document it? Should we do it in a table level, or we have to document in the unit code, or we have to document everywhere?
Soren, I would say that's your domain.
I'm not sure I understand. Document, how? What do you mean with documenting?
Like why we created this method, what's the use of it? Because every developer create their own methods, when they are doing customization.
Yes. Yeah, and I think one of the biggest things that we are missing in the community, that is, we're missing to do proper source control, proper product management of the system. If you have a bunch of developers doing each their own thing, then I'm pretty sure you're missing some product management. That we need to go away from the thing of, we need something, can you go and make me something and see, then come back in 2 weeks and maybe that's what I need, maybe it's not what I need. We need to change the way we think about development. Stop doing our individual thing, sit down, figure out what it is we need, figure out how this should function in the bigger picture before we even start putting one line of code into the system.
Normally you would have a ticket or a work item, if you think in the TFS, which defines the business case. And then you develop against that, and then you end up with having the code and the delta, and with the business case all in one place that you can look up. I know that a lot of us don't work that way, and especially not in the if you have to hurry in a project, but that's actually how it should work. Commenting inside code for us is actually only a workaround. Like commenting your business logic inside objects is just a workaround.
A question about delta files. I would like to ask what kind of differences contain delta files, because all examples that you showed include only fields, differences in fields. Does it mean that it includes only fields differences or also functions and...
No, the delta files contain all the differences. So it also contains differences in code. It contains differences in pages. If you add elements, if you remove elements, it's basically a complete new way of describing documents. So. Yeah, that's a good question. I actually don't. It doesn't. No. So I figured that. So it doesn't contain the deltas for the reports. The reports I would approach in a different way. I think the fact that we can have different layouts on top of one data set is a great asset. And I really hope that if we create one data set and have different layouts on it, that I really hope that dramatically reduces the possibility of us ending up in merging. You can basically, if a new software version ships and you add something to the data set, that doesn't mean that the layout breaks. So I think the necessity of merging layouts is not as big as the necessity of merging code. But it's a good question. Thank you. Yeah.
I think
okay,
we need to start,
one more, not really
we're
a
already
technical...
almost 15 minutes over time.
This is a not technical question. Mark, you mentioned about your book.
Okay, yeah.
I'd like to learn more about what I just heard over the past hour and a half. Is your book about this? Where can I get it and so on?
No, the book does not deeply cover PRS methodology. It maps the functional areas of NAV, and it actually contains a whole bunch of design patterns. It does include natural language programming and hooks. So it's basically a combination of PRS and development and architectural best practices.
And the other answer to the question is Amazon.
Yeah, you can acquire it at Amazon or at Pack Publishing. Thank you.
Thanks a lot. We do that tomorrow.